All right, so welcome to the Collectibles Masterclass or the NFT Masterclass. I think we kind of mixed up the names here, but tonight I'm super excited to share with you how to create your own non-fungible token on Ethereum with smart contracts. Okay, so you can use this for your own crypto collectible project. I'm going to show you how to set it up, customize it, sell it in a marketplace, list it so that other people can buy it, trade it around, put it in your wallet, all that kind of stuff. Okay, so this is all super cutting edge technology that's trending right now. We're seeing NFTs make a resurgence. They hit a big boom at the beginning of this year, but they're making a big comeback. And I've had a lot of people ask me about this, how to create your own crypto collectible, how to actually get inside of this, and that's exactly what I'm going to show you how to do tonight. So, we got people jumping in the chat here. We've got. Let's see, we got Cryptechnology, DFW Play, Adgar, Aaron, 9-Bit, Harry, Simple Habits, NHR, welcome. So somebody says, is this the evil masterclass? It's a shadowy supercoders, right? So yeah, let's go ahead and jump into this. A little bit of housekeeping before we begin tonight. If you're watching this inside the membership program, we do have a special members chat for that. So make sure you put your chat in the YouTube chat because that's what I'm going to be watching tonight. And I'm going to be presenting this content in a step-by-step fashion tonight. But I won't be able to look at the chat every step of the way. So whenever we get moving, I'll try to stop and address chat questions kind of as we go. But we'll have an extended time of question and answer at the end of our presentation tonight. So we can hold the bulk of the questions towards the end. So let's see here. Yeah, totally. So the other thing I wanted to mention was what I'm going to show you to do tonight is definitely how to set up your own non-fungible token, crypto collectible, how to customize it, how to create a website so people can buy it, all that type of stuff. So what I'm going to do is actually deliver you the final code solution for this tonight, show you how to customize it. So we're not actually going to go through a step-by-step coding process tonight. That's going to be more for the blockchain bootcamp portion, which I put a link to down in the description below. If you're in part of the mastery program or you join tonight and you want to get the step-by-step coding skills, which is going to help you do this more, you can definitely check that out. I put this kind of link down in the description of the video tonight for anybody who joined and wants access to that. So, but what I'm going to do tonight is give you the entire solution, show you how to set it up, show you how to customize it, put it on a website, put it on an IPFS, and actually I'm going to show you how to deploy this to a layer 2 scaling solution for Ethereum. So if you're brand new around here, you don't know what that is, this is going to be a bonus section of the masterclass for this particular one where we're going to actually show you how to deploy your NFTs to a layer 2 so that they're faster, they're cheaper, send around, all that type of stuff. So a lot of exciting stuff to cover. And also, if you join the masterclass tonight for the one-time attendance, and you want to get ongoing support, access to all the past masterclasses that we've done in the community chat, weekly updated videos on the hottest blockchain topics like DeFi, NFTs, trading bots, all that type of stuff. Layer 2 scaling solutions, everything as it comes out, we do those inside the Blockchain Mastery Membership Program. And so if you sign up for the one-time masterclass tonight, you actually want to become a member of DApp University, like a lot of the people in the chat are here, just make sure you reach out over email. We can get you taken care of. All right, so tonight let's look at a quick overview of what we're going to cover. All right, so number one, we're going to talk about, what are non-fungible tokens. So we'll start off with some really high-level stuff because what I really don't want to do is I don't want to assume that everybody here knows everything. So we're going to start with some really beginner, basic level stuff, and then we'll just step through it one by one, okay? But if you understand a lot of this introductory stuff, we're gonna get to the part where you get a lot of value out of getting the project and customizing all that stuff pretty quickly. But I want to start off with some basic concepts, just in case somebody's showing up tonight, they don't have a strong background in blockchain, all that type of stuff. And the good news about the coding section of this tonight is that you don't have to be an advanced coder to follow along. As long as you can follow instructions step by step, then you'll be able to do this. So what are non-fungible tokens? We're going to talk about what can you do with non-fungible tokens. All right, and how to create your own. I'm actually going to walk you through the steps on how to do this. We're going to actually set up a smart contract. We're going to show you how to add your own custom artwork for the non-fungible tokens. We're going to put it live on a blockchain so that people can actually use it. And then talk about some solutions for the high gas fees for NFTs, like I was talking about towards the end of this setup. How to actually sell the non-fungible token, hold it in your wallet, send it around, all that kind of stuff. So you're going to get everything that you need to launch your own project tonight. So let's take a look at number one. What are non-fungible tokens? Well, there are different types of tokens on Ethereum, okay? And really, there are two different types of tokens fundamentally. Let's just look at those words and understand what they mean. So you might understand an example of a non-fungible token as like a crypto collectible, for example, like a crypto punk. Let's just look at those as an example for like an archetype of a crypto collectible. Basically, this is a digital asset that's stored on the blockchain. It is provably scarce. It has a specific owner. That owner has full rights over this particular asset. They can send it to somebody else. They can sell it in a marketplace. They can hold it in their wallet. All right. They can, and whenever they transfer the ownership to somebody else, that same provable scarcity will be delivered to that next person. And they have all the full rights and privileges that the previous owner did. Okay. So what makes this work? All right. So basically, all of this, what these crypto collectibles do is they're powered by smart contracts. Okay. All right. These smart contracts, they live on top of the blockchain. And these smart contracts are just programs or code that run on top of the blockchain. And in this case, we have a token contract. And this token contract basically determines who owns which crypto collectible. And, it facilitates behavior for sending the crypto collectible to another person's wallet. If they decide they don't want to own it anymore, they want to send it, maybe they want to sell it inside of a marketplace. All the behavior for the token, this actual crypto collectible, is governed by this smart contract. And then that smart contract lives on top of the blockchain. That's what enforces the digital scarcity for the actual token. Because when it's on the blockchain, once you've put information on the blockchain, it cannot change. It's a public ledger that's shared across, the public network. And once you've put this token on the blockchain, it's there forever. Anytime, you make a change, or anytime that you do something to it, like you assign the ownership of one token to somebody, that ownership is now permanently written to the blockchain until that owner decides to send it to somebody else. Okay. And so that's how they get their value, is they are scarce. You can't make more of them if the smart contract determines that. All right. They can be sent to other people if the smart contract determines that, but they can't, you can't just make more of them. All right. They're provably scarce. You can't duplicate them. That's where the value of these collectibles comes from. All right. And so these tokens have two parts, which we'll get to later. The images themselves aren't actually stored on the blockchain. The images are stored somewhere else, but the ownership rights and the reference to the images is actually stored inside the contract. And this contract is a token contract. So the non-fungible token side of it, that's the token side. So non-fungible token. So that's where token comes from. Token is the smart contract that's on the blockchain. It determines who all owns these digital collectibles, and it lets them send them around, hold them in their wallet, all that type of stuff. Keep track of the images. Now, let's look at what non-fungible means and understand what a non-fungible token or NFT is. So we found out with token, but think about other types of tokens. All right, so let's look at a different Ethereum-based token. Let's look at the Aave token. So this is a cryptocurrency built on top of Ethereum. It's called Aave, AAVE. It's for a different decentralized finance or DeFi project, and it's a cryptocurrency. It's a coin. All right, it is a token. All right, but it's not a non-fungible token. It is a fungible token. It's a fungible. All right, so we're gonna get to non-fungible in a minute, but this is a fungible token. So what does that mean? Well, it's a cryptocurrency. It's a token, first of all. So it lives on top of Ethereum. It's governed by smart contracts, just like the ERC-721 token is. But it is fungible versus non-fungible. So what does that mean? Basically, that means that any Aave token can be interchanged for any other Aave token. It doesn't matter which one you have. They can be traded for one another. So, for example, this Aave token has a total supply of 16 million tokens. All right. And so if you have Aave token number 1 and you want to trade it for Aave token 16 million, the first one that's ever created with the last one that's ever created, it doesn't matter which one you have. They're completely interchangeable. That's what a fungible token is. That's what fungibility is. You can think about fungibility as being, interchangeable. Fungible means kind of interchangeable in this case. So what does non-fungible mean? Well, it essentially means that you can't necessarily interchange one item in the collection for another. So if you look at CryptoPunks, for example, let's say I own this specific CryptoPunk. I wouldn't necessarily be able to trade it for this CryptoPunk over here because they're not necessarily worth the same. Maybe somebody thinks that this CryptoPunk is more valuable than this CryptoPunk. Well, they might be priced differently for this reason. Or maybe there's more CryptoPunks that look like this one than there are of this one. Maybe this one's more rare. Okay, so you could think about this outside of other digital collectibles with, trading cards, maybe Pokemon cards, or if you're in America, like baseball cards or something like that. Or basically, a holographic Charizard Pokemon card might be worth a lot more than some other, less valuable card. That's what non-fungible is. There's a hierarchy of the tokens in the collection, and they can't necessarily be interchanged for one another. And so that's where NFTs come into play, non-fungible tokens. They're digital collectibles. Well, this is one use case of them. Digital collectibles that live on top of the blockchain, powered by smart contracts, and they are non-fungible. All right, so let's just see if we got any questions inside of here. Okay, so that's a basic overview of what non-fungible tokens are. So what can you do with NFTs? All right, so you can do more with NFTs than just do digital collectibles. We're going to talk about digital collectibles and focus on those tonight, digital artworks, because that's the main trend right now. That's sort of a hype around NFTs, and not just total hype. I mean, I think there's a lot of cool stuff about the digital artwork, digital collectibles, but that's where the real trend is right now, is surrounding these use cases. But the cool thing about NFTs is you can do a lot more with them than just this. Okay, so anything that's non-fungible that could have ownership on the blockchain that could be sold could potentially be sold as an NFT, where digital ownership and scarcity makes sense. So think about concert tickets, for example, or sporting tickets, just event tickets. So every ticket, let's say you buy a ticket to a movie, for example, or concert. Well, different seats have different value at that concert, right? A front row and center seat is way more valuable than a seat way in the back. Okay, and there's only one front row seat in the center, right? Maybe there's one next to it. Maybe they're both equally apart from one another. But the whole point is those one or two seats could be 10 times more valuable than some random seat in the back corner. Okay, so that's another example of something that's non-fungible. And those tickets a ticket really is a contract in one sense, in that it's a contract that you have the right to a specific seat at a specific venue for a specific event at a future date and time. And that's where the smart contracts come into play. You could have smart contracts that are non-fungible tokens that represent tickets to concerts. Okay. So we're not going to necessarily create a concert ticket NFT tonight, but that's one of the things you can do with it. You could also do things like, insurance contracts. Okay, where you have something that is non-fungible that essentially represents the coverage that you've purchased against any problem that might happen for insurance. Okay, you could expand this to maybe even things like medical records, or not, it's not medical records, but public records. So deed to a house, for example. Okay, some of these things are a little more speculative, a little more farther out down the road, just because of a lot of the regulation that's around these types of use cases and other problems with technology. Like, you don't necessarily want medical records being public on the blockchain, but for public records like deed to a house or something like that, this is already public information, so you could conceivably put it on a blockchain, but there's still regulatory hurdles for overcoming that. And so that's one of the reasons that non-fungible tokens are so amazing, is because, well, with digital collectibles, is there's really no regulation around it, to my knowledge, in the sense of, it's just, you're just creating digital artworks that are for sale. People can collect them. They can sell them for more. But you don't run the same regulatory risk for creating your own collectible token as you would a cryptocurrency, for example, right? So creating a cryptocurrency, putting it on the blockchain could definitely have regulatory risks, because people think you're trying to, create an unregistered security versus a piece of digital collectible. It's really just, it's just a collectible. And another, let's see here, another use case. Actually, hold on a second. So now let's talk about how to actually create your own. All right, so I'm going to show the code here in a minute. We're actually going to get that set up. But first, I want to dive in more to the actual collectible smart contracts, okay? So let's look at the architecture on how a collectible smart contract works. All right, so let's actually look at, let's see here. Let's look at this. So I'm pulling up an example here. It fell off my screen. All right, so let's just pull up a recent NFT project. Here's another example. So let's look at the Doge Pound NFTs, okay? So I'm actually going to just do this here. There. So what I'm going to do, you can actually explore other NFTs on Etherscan. I'll put a link to this in the live chat here. So I just want to kind of give you an understanding of how an NFT works a little more firsthand. So I'm actually looking on Etherscan right now, which is just a block explorer. It's a website that lets you examine all the activity on top of the Ethereum network, okay? And what I just linked to a second ago is basically a website, a web page where you can look at all the details for this particular token, the Doge Pound. So this is a new NFT drop that came out recently, okay? And so we're just going to take a look behind the scenes at how this works. So you can see all the information about it. these are all the recent transfers. These are all the different addresses that hold this particular NFT. All right. You can look at the inventory. But what I really want to look at here is the contract source code. Okay. So let's just see here. Actually, look at the contract. Okay. And so really you can see it's just one file. All right. One big file here. All right. And what this contract is it implements something called the ERC 721 standard. And this is something that is going to be pretty common across almost all of these crypto collectibles, with the exception of a few early ones, like CryptoPunks, for example. Is that they're almost all of them are going to use this ERC 721 standard, which you can see the code here. So what does that mean? Well, ERC 721, the number is not significant, but ERC stands for Ethereum Request for Comments. So basically, anytime we have new improvements to Ethereum proposed, they turn into EIPs. You might have heard of EIP 1559. And then once they get elevated, as standards, they turn to Ethereum Request for Comments. Okay. And so that's what ERC stands for, Ethereum Request for Comments. So ERC 721 is just a codified standard that determines how these ERC 721 tokens work, or non-fungible tokens, how they should work. So you might have heard of ERC 20 tokens on top of Ethereum. So ERC 20. Well, this is just a standard that governs how cryptocurrencies that are built on top of Ethereum should work. So ERC 20 is just a standard that says, hey, if you want to build a cryptocurrency, you want it to be supported by wallets and exchanges, all that type of stuff, here's a set of rules that specify how this should be built. So similarly, if you're talking about a non-fungible token like a crypto collectible, and you want to say, hey, we want your non-fungible token to be supported by wallets, we want you to be able to list it on marketplaces like OpenSea, for example, then you need to use this ERC 721 standard here, okay? And so really this is just a standard that governs how these non-fungible tokens should work, the types of functions that they should have, all that type of stuff, okay? So let's just go ahead and look at the code for ERC 721. I'll put a link to this in the live chat here so you all can see it. Basically, this is a summary of the standard here. I'm not going to go through all the details, but you can see that it's essentially just a template that shows what your contract should do. So here you can see an interface, which is just a definition of how the smart contract works, with some specifications inside of it. So for example, your token must have a transfer event. So essentially anytime you move a token from one account to another, it has to trigger this event so that somebody listening to the smart contract can pick up on this, right? It also needs to have an approval event. So anytime someone wants to approve the token to be spent, it needs to have that. It needs to have a special function called balance of, okay? And that function has to take a specific argument, and basically this function needs to return who the owner of a specific token is, sorry, what the balance of a specific token holder is, how many tokens they have. The same type of thing. It has to have a transfer function, which basically lets people send tokens from one account to another, all that type of stuff, right? That's what the ERC 721 standard is. This is the primary way that we create crypto collectibles. And if you're going to create your own, then you want to use this, and that's exactly the standard that we've used for the smart contracts for the template tonight. All right. So the other thing that I want to talk about is the architecture for the tokens is basically, I talked a minute ago about how you have an ERC 721 contract. For the token, you have a smart contract with the ERC 721 standard. And this is really going to govern, how people, interact with the token, show them in their balances, all that type of stuff. But then you have the image for the token, okay? So you have an image like for these CryptoPunks. Well, these images are not stored inside the smart contract. So why is that? Well, basically, the image is way too big to be put on a blockchain. The blockchain is not really meant for large amounts of data. So you store the data, what's called off-chain, so in a different location. And then you basically, inside your smart contract, you store a link essentially to where that information exists. And so when you open the collectible in your wallet, it can talk to the blockchain to verify that yes, you do own that. And then it can ask the blockchain like, hey, where is the picture for this collectible so that I can show it on the page? And then the blockchain smart contract will actually tell the wallet or whoever's requesting that information where the location of that image is so that they can display it on the page here. So you could display this image in a variety of places. You could put it on a web server and generate a link, okay? But instead, we're going to use something called IPFS, all right? So what is IPFS? Well, IPFS stands for the Interplanetary File System, all right? So this is somewhat, but basically what this allows you to do is store files in a somewhat decentralized way that's very compatible with the blockchain. Okay, so it's kind of like a blockchain or distributed system for sharing files, but it's not really a blockchain. It's just a peer-to-peer file service where you can put files on it and then read off of them. But what we're going to do is actually put the images for the collectibles on IPFS tonight, and then we'll store a reference to those images inside of our smart contract, okay? So we'll create our own crypto collectible images. We'll put them on IPFS. We will deploy a token to the blockchain, and then for each individual collectible that we create, we're going to put that on IPFS and then put a link to the IPFS images inside the token contracts. And that's sort of the two main pieces that we'll need in order to create this token. So that's the thing about IPFS. The benefit of IPFS is once you put the file on IPFS, it's just there on IPFS. So you don't have the censorship problem. You have to worry about the file going down like you would with a web server. That's why people like to use IPFS, because it's immutable, and as opposed to a web server, which the file might get changed. So you could make a crypto collectible with a link to the image on a web server somewhere, but it's less desirable than having the link on IPFS. All right, so let's go ahead and set the code here. We've got a couple questions about IPFS. We'll circle back around to those towards the end of the presentation tonight. Let's actually get into some setup here. Is there NFTs worthy for copyright? Yes, I believe that there is rights associated with the original artworks. So somebody says the code link available yet. There should be a code link. Let me just see here. Let me make sure it's in the description. Yeah, okay, so the code link is in the description below, along with the other resources for the project, okay? So go ahead and download that, and we'll go get started here. And one thing is, you know, if you're brand new tonight, again, this is not going to be a step-by-step coding program. I'm going to show you, set everything up, but it may be challenging for you to follow every single step as I'm doing it. So if you get behind or something like that, it's probably best to just get a big overview of how to set this up tonight, and then maybe rewatch it if you get stuck. If you're fast and you can follow on quickly, by all means do that. But if not, then you know, it might be better just to watch the replay and actually follow the instructions step by step if you get stuck. So. All right, so yeah, there's a link down below to a zip file to this particular GitHub project. All right, so go ahead and download that and open it in your terminal. I'm gonna show you how to do this. I'm gonna open mine here. All right, so let's go through the setup steps about what you need to get started here. All right, so somebody says, how much previous coding knowledge do I need to apply this now? Am I going to sign up for the blockchain bootcamp or apply this knowledge? So you definitely, if you want to get into more advanced coding, then I highly recommend the blockchain bootcamp. I had a lot of people on the stream tonight who've gone through that program, especially inside the membership program. However, you do not need to be an advanced coder in order to follow along with the steps tonight. We will be using code on our desktop here. There are places where you'll edit the files, but it's pretty clear. We've had people go through this type of stuff before who are not advanced coders who were definitely able to get the result. But if you are an advanced coder, you'll have a lot of power to do advanced customizations that we won't quite cover tonight. Yeah, the link is down in the description below, everybody. All right, so let's go ahead and talk about some prerequisites you need in order to follow along with this. So the first dependency you need to install on your computer is Node.js. All right, so I'm not going to set this up live on screen tonight. I think most people who have done any coding will have this already. If you haven't, you don't have it on your computer tonight, you definitely want to set that up. It'll take a few minutes to download Node for the first time, okay? And you can see the instructions here. All you have to do is run this from your terminal, and you can run, you know, Node like this. And you can actually see if you have Node already installed by going to your terminal and typing node-v. Okay, so I'm using version of 14.16.0. All right, and that's the exact version that we specified for the class tonight. So if you want to make sure that there's no problems, and I highly recommend using the exact same Node version as me, if you want to ensure that you don't have any errors. If you want to update or change your Node version, you can install NVM, or you can use a tool like N to change that. Okay, the next dependency that you need installed is the truffle framework. Okay, so let's look at that. Let's see what truffle is. So truffle is a smart contract development framework. So again, smart contracts are going to be the core of how our token works tonight. Basically, we're going to have a smart contract written in Solidity, the programming language for writing Ethereum smart contracts for the token. And we use something called a framework, which is really just a tool that software developers use to write applications. And that framework, you know, has an entire suite of tools that you need to build your software, so you can write tests for it, so you can deploy the project, so you can create a website for it, all that type of stuff in one place, so that you don't have to do everything from scratch. That's what a framework is. And so Truffle is a framework for developing smart contracts on Ethereum. And so this framework is really just going to be something you kind of install on your computer, and then you can create software projects that are compatible with this framework, and that framework will let you, do things like run tests, deploy the project, create new files, all that type of stuff. So this framework is Truffle, and we can, install Truffle with Node, which we installed in the previous step. All right, so you can see we have Truffle already installed, like this Truffle version. Well, a second, let me just change this. And if you don't have Truffle already installed, then you can do this. It's npm install -g Truffle. Okay. So this instructions are right there inside your project. And also, you can see me watching these instructions on the screen. You can actually look inside your project here, and you can see those. You can see those inside of this readme.markdown file. You can see all the raw text for that file that I'm looking at on your screen. So if you want to copy any of these commands, they're inside of this readme file. So like when I look at the Truffle version, you can just copy that right here and put it in your terminal. Just make sure you don't copy the $, because that's just a symbol that lets you know that you're doing it inside of the terminal. All right, so let's finish. All right, so it's almost done here. So the next thing, while that's getting finished, the next thing we want to do is actually install a development blockchain, okay? So I want to show you sort of a diagram for how this project's going to work tonight, all right? So we're going to have our project here, Truffle project, all right? And so this Truffle project is going to contain the smart contracts for our application, okay? And this Truffle project is going to talk to multiple different things, all right? So the first thing we want to do is actually put our smart contracts on a blockchain where we can just test stuff out without having to worry about spending any real money, without having to worry about whether we can break things or anything like that. So we're going to have a development blockchain. Okay. So this development blockchain is something we can point our Truffle project to, so that we can just deploy smart contracts to it without risking any real money. We can run tests against it, all that type of stuff. All right. So that's something called Ganache. All right. So Ganache. One second. Ganache blockchain is just a one-click blockchain that lets you install a blockchain on your computer, so you can do everything that I've talked about here. All right. So you can see here that this is Ganache, the graphical user interface version, so Ganache GUI. All right. But we're going to use the command line version of Ganache tonight to make things simple. So instead of doing that, instead of like running an app on our computer, we're actually going to install Ganache CLI like this. So you can just copy this, install the command line version of Ganache from your terminal. I'm just going to open a new tab here. So whatever terminal you're using, whether it's a Mac, Linux, Windows, should support multiple tabs. And so that's what I'm going to do tonight. So you can see I actually have Ganache CLI -- version installed here. But if you don't have it installed, you can just do npm install -g ganache CLI, just like this step right here. You can just literally copy this, paste it in your terminal, and install it. So I've already got it installed, so I'm going to skip that step, but you definitely need that if you don't see it installed. And now we can go ahead and start this development blockchain. So I'm just going to do ganache -CLI, and this will actually start a new blockchain on our computer, okay? And now you can see we have this running where we have 10 accounts for free. This is a Ethereum address right here, sort of like your username on the blockchain. And you can see it's already funded with 100 fake ether, so don't get too excited. This is not worth any real money. It's all just fake ether, so you're not spending any real money here. And then you have these private keys, which are sort of like your password, okay? So you definitely don't want to use any of these accounts that I've showed on my screen tonight here for real, because anybody who has access to this type of stuff could steal your money. Same thing with this mnemonic seed phrase here. You definitely don't want to show this to anybody. Don't use it for real because people can steal your money. Okay, so that's the next step. So we've downloaded the project. We set up the Ganache blockchain so that we can actually deploy the smart contracts to it, right? So next thing we want to do is, remember I talked a minute ago about how our token consists of two parts. It consists of the token smart contract, but also the images for the token, all right? We need to be able to put the images on IPFS, all right? So what we're going to do tonight is actually deploy the images to IPFS, and we're going to run our own IPFS process on our computer here, all right? And that's exactly what our truffle project is going to connect to as well. In addition to this Ganache dev blockchain, we're going to run IPFS. We're going to run an IPFS process on our computer where we can store images, all right? And we're actually going to connect our project to it. So truffle project is going to connect to IPFS. It's going to connect to the development blockchain here. And so now we want to go ahead and install IPFS. So you can see if you have it installed by going over here to your terminal. Again, I'm opening a new tab here and doing JS IPFS version. If you have it already installed, you'll see the version here. If not, you can just run this from your terminal here, npm i-g IPFS. Again, you can just copy and paste this from the description below. Description in the code, but just don't use the $sign. All right. So I'm going to skip this step, but if you don't have it installed, whenever you check the version, you definitely need to do that. Wait for it to finish. So the last thing I'm going to do is actually install start the IPFS daemon like this. So JIPFS daemon, and boom, there we go. So now you see we have a connection available here on our local host on this port. Okay. So now we've got a blockchain running. We have IPFS running. All right, making some progress. So next thing we want to do is actually install the dependencies for the project. So basically, let's go ahead and open it up in our terminal here. I'm going to open mine in Sublime Text. You can use whatever text editor you'd like. If we have people tonight who are not super advanced into coding, you can download any text editor that you want to. Again, I'm using Sublime Text. You can download that for free. You can just Google Sublime Text, okay? And then you can just go to the website here. Just click download for whatever operating system you have here, and it'll download it. All right, so that's what I'm using tonight. And if you don't have the fancy command to open it from your terminal like I do, don't worry. That's just a shortcut. You can very easily just go File, Open, all right, and open the project that way. Somebody says they like VS Code. Yeah, you can definitely use VS Code if you want to. I'm just a creature of habit. Sublime Text works well. I've used it for many, many years. All right. So inside of here, I want to point you to this file here, this package.json file. So this this file has a bunch of libraries that we need to make our project work, like the Web3 library, for example. This is a library that turns our website that we have inside the project, turns into a blockchain website. And so we need to basically download all these dependencies for our project. And that's what NPM does, or Node that we installed earlier. But specifically, we're going to use something called Yarn today. So Yarn is a package manager for Node.js. Works a little bit differently than NPM, but we're going to use it tonight. So you can check to see if you have Yarn already installed by going yarn -- version in your terminal here. If you don't have Yarn already installed, you can install it like this: npm install -- global yarn. All right. Okay. And you want to make sure that you've entered into your project directory. Okay. Before you do this, you want to do yarn install to install all the packages for your project. All right. Smith has encrypted data on IPFS with decryption key and contract with owner permissions. Would that allow someone to disable NFT? So if you had the decryption key in the contract, it would still be publicly available information. Okay. So the GitHub repository, somebody's asking about that. The GitHub repository is private, but there is a zip file in the description below. If you go to the, if you're watching this video, either in the replay inside the video vault, the file should be listed below. If you're watching live tonight, there should be something that says code, and then there's a link to download the file, zip file, in the YouTube description. And if you're watching the replay from an email, then the link to that code zip file should be in those resources section as well. All right. So now, let's go ahead and see if this worked. We're going to do a test here just to see that everything's set up properly. We're going to run truffle, compile, all right, from our terminal like this, and see if we get any errors. If we don't get any errors, then we've passed the first step. All right, awesome. So we passed the first test. Everything is set up properly. The contract's compiled. So we'll get into that here in a minute. But let's go ahead and open up the project and take a look here and see how this works. Okay. So we can go ahead and get a tour of what's inside the project. All right. We go to the source directory. This is where all the code for the project is going to live. That's what source stands for. Anything outside of source is really just configuration for the project. We have the back end here. All right, this is where the smart contracts are. And then we have the components and images. All right. So let me do a quick diagram of how the project works. So essentially, our truffle project is broken up into two parts. We have the back end. We have front end and back end. We have back end. So the front end is going to be a website where people can actually go, look at the NFT and, purchase it. They'll interact with it. Okay, so this is a website. And then the back end is going to be the smart contracts. Okay. So the smart contracts written in Solidity deployed to Ethereum. And the front end is going to be a website with JavaScript and React.js. All right. We won't get too far into the React coding tonight, but I just want to give you a sense of how this works. So the back end is where the smart contracts are. This is where the token is. And then we also have the images in a separate directory where we'll, set everything up that way. All right, so let's get back to the project. So you can see the backend contracts, and then find nft.sold. All right. So this is the file for the smart contract that governs the token. You can see it's just one file here. It's not too crazy. If you're not an advanced coder tonight, hopefully this doesn't overwhelm you. This is really just a template that is you can customize. And the good news is, if you want to customize it for your own project, you really only have to change this line right here. Now, if you're an advanced coder and you want to, get crazy and code a bunch of extra stuff in here, feel free. But if you're not super advanced and you just want to customize your own NFT, then this is the only line that you have to change. So what are we looking at here? So this is a smart contract. This is the Solidity programming language. This is the primary language used for writing Ethereum smart contracts. It's a pretty simple language to understand just by looking at it. Of course, not easy to code it from scratch if you're a beginner, but the whole point here is you can kind of just glance through this and see what's happening. You can see there's a contract keyword here. It's called NFT. It uses the ERC 721 standard. It's ownable, all that type of stuff. You can see the functions. Like you can see that this is one function called mint. This is one function called buy. All right, validate, all that type of stuff. Right. So this is an introduction to the token, right? So we also see other places inside the contract, inside the project. We have the components. This is for the website itself. All right, we'll go with that here in a little bit. But this is the contract. So one thing I want to mention here is that because ERC 721 tokens are a standard, there's a lot of stuff inside of here that's you can be reused without having to reinvent the wheel every time you create a new ERC 721 token. Okay, and so for that reason, we're going to use something called the Open Zeppelin library. So Open Zeppelin is a library for Solidity smart contracts that's really well tested. It's been audited, and so you can create secure smart contracts without having to reinvent the wheel, especially really common smart contracts like non-fungible tokens or NFTs with this ERC 721 standard. Okay, so we're going to use the Open Zeppelin contracts. We've already pulled them into our project. We're going to use them as a template, and we're basically just going to customize them. So you can see that imported here at the top. Because we imported the Open Zeppelin contract token, ERC 721, and then the ownable contract, okay? And then we've just configured our smart contract to actually inherit from those right here. And so if you want to customize your token, I'll show you how easy it is to do it. So every token has a name. So let's see your tokens. Has a name and a symbol. So the name, it could be whatever you want it to be. It could be CryptoPunks. And the symbol could be, punk. All right. And so you can see that actually inside of here. You can see the name. I've already pre-coded it here. DApp University, and the symbol, DApp U for the token. So we can customize, you can change these things here to customize this for your own NFT tonight, all right? So we can call it, let's call it Shadowy Supercoders. How about that? Okay. We'll call it Shadow as the symbol. This is an inside joke for something that happened this past week. People talking about, shadowy supercoders being the people who are coding for blockchain. And so now it's become an inside joke. So that's what we're going to use for our, our NFT tonight. But you can change this to whatever you'd like. So what linter do I use? I'm not actually sure off the top of my head. I set it up a long time ago and forgot. So this is the first step to customize if you want to do that. All right, so next let's next, let's go ahead and migrate the. Let's go ahead and test out the contract. Let's follow the steps here. So we're going to go ahead and put it on the blockchain. And so let's go ahead and actually do this again. We'll do truffle compile. So what compiling does is basically takes our contracts from human readable code here. That's what we're looking at. Source code is human readable code that I can change. And then go through this thing called the compilation process, where you take this human readable code and you turn it into byte code or machine readable code that actually gets put on the blockchain and run on the Ethereum virtual machine. And so that's what this truffle compile does, is it converts your code from human readable code to machine readable code. And so now what I can do is do truffle migrate -- reset -- network ganache CLI. So you'll see this. You'll see this on the thing here. So truffle -- reset ganache CLI. So this is any guide on how to programmatically generate NFTs like CryptoPunks. So yeah, you can definitely do that. I'll kind of talk about that towards the end of the class tonight after we see how to mint your own NFTs. But that's the whole idea. All right, so now we have put the contract on the blockchain. So our token's now on the blockchain. We've customized it. We've called it Punks. And so I want to point you to a file that facilitates that. If you go to source backend migrations, you can look at this file called deploy. Basically, this just takes your smart contract and puts it on the blockchain. So I won't get too far into the weeds on how this works, but that's where the file is. It does this. All right. So now we've put the contract on the blockchain, but we actually want to customize it even more and create the images themselves. All right. So I talked about how basically the token has two parts. It's the token plus the images on IPFS. We have taken our truffle project, we've set it up to connect to this development blockchain and also IPFS. But how do we actually add the images? Okay, so the tokens on the blockchain, the smart contract that governs all the tokens is on the blockchain, but the actual tokens, like each collectible, has not been created yet. All right, so let me explain that. So basically, what's going to happen is we have put this contract out there. But it doesn't have any tokens yet. All right. So, you can have like token number 1, token number 2, but they don't exist. All right. So how do we make them exist? Well, we do what's called minting them. All right. So we mint. So we have 0 tokens, even though we have this token contract that creates tokens. But we're going to use this function called the mint function, which you can see here. All right, what this function does is it takes a URL and a price for the token, and it adds them to the smart contract. All right, and so what we can do is actually use a script inside of here to mint a bunch of tokens all at one time. All right, so if you go to let's see here, source scripts. And then you look at mint.js. All right. So this is a file. It's somewhat complex, so I won't go through everything that happens inside of here. But what this does is it actually it creates tokens. That's what it does. It creates these tokens. So what it does is it actually looks in this folder here. All right. It finds all these images in the project, and it creates NFTs based on them. Okay, so basically, we have we've chosen fine art as just sample artwork for the NFTs tonight. But this is where you can actually go replace your project. okay? So if you want to customize your project even more, this is where you change the images. So one thing you can do is you can open your file here. Let me just do it. And you can see, if you look inside the source, backend, scripts, and you look at the gallery, this is where you can add your images, okay? So basically, if you want to customize it, you just put your own picture inside of here, and you change the file names, all right? You can add as many as you want to, all right? So the next thing you want to do, though, is for every single image that you create, you want to create corresponding metadata, all right, for each file. So what we're actually going to do on IPFS is store the images, of course, on IPFS, but we're also going to store something called metadata. And what does this metadata do? Well, it's just a description of the collectible itself. So it might talk about the name for the individual item, the name of the individual collectible. Somebody said, what is Truffle? High level, please. Basically, Truffle is just the framework that lets us create the smart contracts. So if you look in the project here, you know, we have this name and symbol for the token contract, okay? But if you look inside the metadata, you have a name for the individual artwork or the individual collectible here, right? You can see this American Gothic. Here's a description for it, and then here's the image link, okay? So this is actually something that will be created whenever we mint the tokens. You want to change that, all right? This will be created by the script. What you want to do is actually go change the images. And so if you look inside the mint script, what it does is it actually reads the images, all right? And then it basically prepares the metadata, and then it creates the images, all right? So now what we can do is run this minting script and actually create the tokens, okay? So that's what this, oops, sorry. That's the step is here. We're going to run the minting script, so we'll create all the tokens, you know, token 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 from all the images in the folder. So however many images you have inside of here, let's see here. That's how many tokens that you'll create. So this list here is the exact number of tokens that you'll create. So we can do this by looking at our instructions here. And we can say truffle exec. So truffle exec is what tells the project to actually run the script. Truffle exec source backend scripts mint.js network and our CLI. And boom, there we go. We can see all the tokens were minted. And we can see the results on our blockchain here. All right. And so now what we're going to do is actually run the application. So now we've created the token. We've minted all the tokens. We've put the images on IPFS. And so now what we want to do is actually visualize the tokens and look at them on a website, all right? So we have a website inside of our project here, and this is the website that will let people buy the tokens. And this website is in here. So source components, app.js. This is all the code for the website itself, all right? And so this is in React.js. Again, we're not going to go over React too much in the class tonight. It's not meant to be a step-by-step coding program, but I just want to show you that this is what we're using to create the website. React's a component-based library for creating client-side applications. You can create websites with it, all that type of stuff, right? And so we can go ahead and start the website like this. Let's just go ahead and open a new tab here. And we'll do yarn start. And this is going to start a web server on our computer that's going to actually open the website inside of our project here. All right. So let's see if it works. And so one dependency that I did not mention at the beginning of this video that you definitely need to have installed is MetaMask. So MetaMask is an Ethereum wallet, all right, that lets you, let's see, that lets you interact with the blockchain. So most web browsers out of the box will not let you, most web browsers out of the box will not actually support connection to the blockchain itself, okay? That's because they just don't. So you have to install a special browser extension to do it. That's what this is. You can just look up MetaMask, all right? So MetaMask is just an Ethereum wallet for Google Chrome and also a mobile application, which we'll see here later, all right? So you want to have MetaMask installed. Go ahead and open it, all right? And then once you've done that, you'll see your website here, okay? So this we can see all the tokens that we've minted. See token 1, 2, 3, 4, 5, all that type of stuff. And now I'm going to show you how to actually purchase them, okay? So go to Ganache CLI and find one of the accounts in here. All right, let's say, sorry. And find the private key. And then let's just do this one. Copy the private key, go into MetaMask, go to your accounts here, go to import account, paste in the private key, click import, and then you should see your account with balance here, right? And so now you can click on buy. See the price here is 0.01 ETH, all right? Click buy. Actually, hold on a second. I need to change this here. It should have efficient funds. Hold on. I think it's because I'm not totally connected. Yeah, connect. Sorry. Yeah, you got to click connect. Refresh the page. Okay, confirm. And then boom, there you go. Awesome, and you can see it's sold, right? You can buy another one. Click confirm. And boom, there you go. Awesome. So now we have a complete non-fungible token. We have a website where we can sell it. Don't worry, we're not done yet. I'm going to show you to actually put this out there on the blockchain, set up your website so that other people can use it. But this is a major first step, okay? You set everything up at your computer. You can see how it works locally. You can see how you can customize the images. And so we made a lot of progress so far. So there's a few more steps after this, but I want to go ahead and pause here and just kind of recognize this milestone. This is the major first step to make sure you got everything set up properly. So what is the link for the commands instructions? So I'm just looking at this on GitHub. So one thing you could do is you could create your own GitHub repository and push it live to that so that you can read this markdown file like this. But all the commands are inside of your README file here. So if you got a README, this is in markdown format, so it looks a little bit different. But you can see all the commands here, like npm install -g truffle, truffle migrate -- reset network and GUI. It's all inside of here. It's just got some extra characters around it. It says wrong network. So I should have mentioned that. My fault a minute ago. So what you also want to do, you want to change to the network. So you probably see Ethereum mainnet here. All right, so saying wrong network, that's probably the area that you're looking at. So you actually have to add your network here. So if you go to Ganache, you can see it's port localhost 127.0.0.0.1, 8545. Go here, go to custom RPC. So you can say Ganache CLI, put in 127.0.0.1, 8545, and then the chain ID. Hold on a second here. Chain ID you can see here in your truffle-config file. You could do 5777 be fine. And then currency symbol ETH, and click save. So I've already done this, so it won't let me do it. But once you do that, you can add a custom network, and then you'll see the connection here. And then boom, there you go. That's how you connect. All right, so let's talk briefly about customization inside of here. So if you want to create, if you want to create your own NFT and then just like move it straight to OpenSea, you can definitely do that. But if you wanted to sell on a website, this is how you could do the website. So to customize this, you would change everything inside of the components files. You could app.js. You could basically customize all the stuff in here. If you want to look at the main page here, here's where most of the content is. All right. If you want to change the styles, you can look at the style.css. So you're basically, if you want to change, most of the background, you could do it that way. You could change this to just like white. All right. Refresh the page. There's that section. So basically anything has the same color, you could change it. That type of stuff. So you could just play around with the CSS, and that's how you can change the images here. Again, if the customization, for this particular part of the equation is challenging, let's say you're not super advanced coding, and we can go through the coding instructions on how to do this inside of Bootcamp, or there's probably people in the chat here tonight that if you wanted to have some custom implementation done, there'd be plenty of people who would be a great chance for them to get some experience working with somebody else to deliver a project like that. Okay, so they fixed the network. Awesome. And so now let's talk about actually deploying the project off of our computer. Okay, so what I'm going to show you tonight is how to put it on a test blockchain so that other people can use it. All right, so that's the goal tonight, is to get you something where you can send it around to your friends. Of course, if you want to do it for real, sell it on a marketplace, you can definitely do that as well. But tonight, I'm going to use what's called a test network. Okay, just so that when we go through the steps here, we're not risking any real money, we're not spending any real money. But you can look at, so Ethereum supports multiple different networks, and you can see that inside your MetaMask here. You can see this Ethereum mainnet right here. All right, you can see the Robson test network, the Kovan test network. These are all different networks where basically you can, this is where all different networks where you can basically test out your applications without risking any real money. All right, so we're going to select the Kovan test network tonight. So go ahead and go to your MetaMask, change the Kovan test network. All right, and basically we're going to use that as our environment to deploy the application tonight. So if you put your project on the Ethereum mainnet for real, it's the exact same steps as what I'm going to show you here, except you're going to point to the main Ethereum network instead of the Kovan test network. But tonight I'm going to do it on Kovan, so if you're following the instructions step by step, then you just are not risking any real money. All right. So let's go back to our diagram of our project. Let's see if I can find it here. All right. So, we've connected our truffle project to Ganache for the development blockchain. We've connected to IPFS, but now we also want to connect to test blockchain. All right, and this will be Kovan. And then we can also connect it to a live blockchain. All right. And this can be Ethereum mainnet. All right. So our truffle project is going to talk to all these different environments. So the next thing we're going to do is the Kovan test network and also the ETH mainnet. All right. So I'll go ahead and answer a quick question here. Somebody says how to show different prices for the pictures. So yes, you see the price gets injected inside of this file here. Sorry, inside its function call for minting. All right, this is the function that gets called whenever the tokens are minted. So if you go to the scripts for mint, you can see the price here. All right. This is where you change the price. So next, let's talk about how we actually put the project on Kovan. So if you go to this truffle-config file, this is basically so we got a couple questions here. I'm gonna hold off on some of these questions until the end of the presentation so we can get through this next part. So if you look at your truffle configuration file, you can see that it supports a variety of networks. So Ganache CLI, that's what we did here, right? We also have a connection to the Kovan test network right here. Okay, this is a configuration for that, all right? We have configuration for the Rinkeby test network, so you can do pretty much any test network you want to. Rinkeby, Ropsten, these are just different Ethereum test networks. But then we also have a settings in here for the Ethereum mainnet, all right? So if you want to deploy your project live to the Ethereum mainnet, you can do that. We already have the configuration set up for you here. Okay, we're going to use Kovan tonight. So let's go ahead and set our project up to do that. We need some additional configuration. So what we need to do is actually create an account that we can use to act as the deployer. Okay. So our truffle project needs to be aware of a user, so the deployer. This is going to be the person who actually assigns transactions to put the contracts on the network, okay? And so anytime you're putting a smart contract on the network, you're creating a new transaction, you have to pay gas fees in order to do that. And so your deployer essentially has to be an account that is sort of like the developer, and you have to store your private key or like your password inside your truffle project so that your truffle project can sign the transactions and put them on the Kovan test network or on the mainnet, okay? So we didn't have to do that for the development blockchain because all the accounts on there are unlocked by default. What we're gonna do is actually go to our project and store this information inside a .env file, okay? So if you go to this, we have a file called .env example. We can duplicate this. We can just go like this, duplicate, all right? And then instead of calling it .env, .example, just call it .env, all right? And inside of here, we actually want to store the sensitive private information like our private key for our account that's going to connect the blockchain. Okay. So I'm just going to use the private key from our MetaMask account that we imported from Ganache. So I'll show you how to do this. Let's say you're using a different account. Maybe you don't want to use your Ganache account. Maybe you want to use your own MetaMask account. You can just go settings here, account details, and then do export private key. All right, so I'm not going to show mine off screen. I'm not going to show mine on screen here. But once you do that, you'll see the private key for your particular account there, okay? And again, you don't want to use a private key for an account that you're going to store large amounts of money in, because anybody who finds that private key basically, would have access to your funds. They could steal your money. We've had people in the program learn that lesson the hard way. I've personally, I've seen it happen. So anyways, you're going to get that private key and you're going to store it right here. So I'm not going to show mine on screen because I don't want to show these, secret details. It's good practice for me to hide these, all right? But you want to copy your private key and replace it with whatever's right there, right? So the next thing that we want to do is actually fund this account, because we have to pay for gas fees in order to create transactions on top of the Ethereum network. Again, we're a deployer. We want to deploy the Truffle project. We have the accounts in our project. So we can actually get some Kovan Ether for free on the mainnet by just going to this faucet here. Actually, tell you what, we're going to use, we can use Kovan or you can use Rinkeby. It doesn't really matter. Sometimes people have a hard time getting, enough funds from the faucet, but you can click on the faucet here. And we're going to use the Kovan faucet. All right, so I'm going to do Kovan. I'm going to copy my MetaMask address here. I'm going to paste it in here. This faucet is basically just a place that lets you, get some Ether for free. So send me 0.1 test ETH. All right. And so you might need a little bit more than 0.1 Ether to get through all the steps here. So you could come back later and request more from the faucet here. I think it's kind of rate limited, so you can't just, you can click it. I think it's rate limited, so. Yeah, it's rate limited, so you have to wait a little while before you request more. But that's how you can get some fake Ether. All right, so once your account is funded, you'll see the balance here. All right, so you've received some Ether. And so now we have this deployer with ETH in it to pay the transactions for the gas fees. And the next thing we want to do is actually deploy the project to the test network. And there's one last thing we need. One last thing we need is we actually need a connection to this Kovan test network. So that's where Infura comes into play. So if we're going to connect to a blockchain, again, we ran this development blockchain called Ganache here. But if we want to put our project on a test network, we actually need to connect to it. And so you have to connect to an actual Ethereum node in order to talk to the blockchain. Now, it's really hard to run your own Ethereum node. So we're going to use something called Infura, which is an Ethereum node as a service. Go to infura.io. There should be a link in the README, and just go through the sign up steps. All right. Once you've created an account, you can go ahead and log in. You can see your applications here. All right. And so I've already created some projects. I'm just going to go ahead and click on this project. You can go to your settings, and it will show you your Infura keys here. Now, don't use this one. All right. I'll just probably delete this project at some point. So don't use these credentials. But if you go to Kovan or whatever network you're using, you can see the project ID and the project key. All right. So basically, you want to copy this project ID, go back to your .env file, and then you want to put it in a place where it says Infura ID. So this is the .env.example file, but you want to do it in the actual .env file. Okay. So I'm going to put my Infura ID inside there. All right. And then that's all we need. So we've got all the secrets in our project. We've got the project configured to point to the Kovan test network. We've got the deployer account connected to our project. We've funded the deployer account with fake ether. All right, and so now we actually want to put it on the blockchain. So let's do truffle migrate -- reset -- network Kovan. So if you're using a different network right now, let's say you want to use a different test network like Rinkeby, for example, you would basically just change the -- network Kovan to -- network Rinkeby. If you're actually deploying your token for real to the live Ethereum mainnet, you could do -- mainnet. Because again, we have all those configurations saved inside the truffle - config file. So if you're doing main, you do -- main, Roston -- Roston, Rinkeby -- Rinkeby. And boom, there we go. So we have put the smart contract on Truffle, or sorry, on Kovan. So now we want to do exactly what we talked about a minute ago. We've created the token, but now we actually want to mint them. All right. So we want to run the minting script. So we can do that on our respective network. All right, let's go to the instructions here. Okay. So if we're going to actually mint them, you can do the minting script like this. So truffle exec source backend scripts mint JS -- network Kovan. So again, it's the exact same command, but you just run it against the Kovan test network. And so I'll go ahead and run this. And whenever it's finished, we'll have our tokens minted live on the Kovan test network. And so one thing we can actually do while this is finishing is we can basically, you see the output is going here. We can look at our contract. We can look at this transaction hash. We can copy it and go to Etherscan. We can go to kovan.etherscan.io and actually look at the, we can look at the transaction where our contract was created. So you can see your contract here. All right. And you can actually see the token. So you see our shadowy supercoders token here. And we can also see the tokens actually getting created in real time, or you can actually refresh Etherscan and watch them as they're being minted. So you can see the minting happening here, and then we can go to Etherscan, and we can see it picking up new tokens as they're created. All right. So you can see your shadowy supercoders NFT here. And you can also see, these NFTs as they're created. We can click on one, and you can actually look at the metadata on IPFS. You can just paste it in, and you can see, boom, there's the metadata for each thing. And you can actually see the link to the image here. Copy it out, paste it in, and then boom, there you go. All right. And so there we go, we're done. And the last thing I want to show you how to do is now that our token is actually on the live blockchain, you can simply go here to your Kovan test network account, and you can basically, you can change the Kovan test network on your website, and it'll pick up your Kovan contracts. Okay. And then boom, and you can buy your tokens on here that way. All right. So it looks like somebody's already been purchasing them. That's awesome. All right, there you go. It's actually working now. Okay, so the last thing I want to show you how to do is actually add the tokens, to your wallet. So we're going to go here and buy a token on Kovan. All right, we're going to click confirm. Wait for the transaction to finish. All right, there we go. So now we can see this buy function was called, and now we own this particular NFT. Okay. So now I want to show you how to actually add this NFT to your wallet so you can prove that you own it. So we'll do it on MetaMask Mobile first. Let's just click this account, and let's go to Assets. Let's click Add Token, and let's go ahead and copy the contract address here. Hold on. Add token, contract address. You can see token symbol here. So actually, this is for ERC20 tokens. So I think the MetaMask for the NFTs on desktop is not as good as it is on mobile. So what I actually want to show you is how to add it on mobile. So I have a bonus video on this, and I'm just going to play it right now and kind of walk you through how this works. So I'm going to show you with a mobile Ethereum wallet, so you can look up MetaMask. So I have the desktop version of it right here, but you can actually open the mobile version of it, which is right here. You can download on the Google Play Store. You can download on the Apple App Store. All right, but this is a mobile Ethereum wallet that you can download to look at your NFT. So you want to import your account, inside your MetaMask wallet for sure. But once you've done that, here's how you actually add it to your wallet. So you'll see your account here, and then basically, you'll click on collectibles. All right, and then once first of all, you want to change your network. So click on this top button right here. Change to the Kovan test networks. Change from Ethereum mainnet to the Kovan test network or whatever network you're using. And then basically, you want to click on the collectibles tab here, and you'll click on add collectibles. All right. You'll paste in the smart contract address, so you can find that, right here on Etherscan. Okay. You can text this to yourself on your phone or something, or email it, and you'll add the smart contract address there. And then you want to add the ID for the token. Okay, so what's the ID? You can see that on Etherscan here, ID number 1. So you could paste that ID inside of there. All right. And then click add. And then whenever you're finished, boom, there you go. It should appear just like that. Boom, there you go. And that's how you actually see your collectibles inside your wallet. Okay, so now we've actually launched an NFT. We showed you how to customize it. We showed you how to set up a website for it, how to customize that website, how to put the NFT on the blockchain, how to put it inside your Ethereum wallet. Now, there's a couple other things that we didn't cover tonight in the video that I'm going to link to in the description down below. There's some bonus topics, okay? So bonus topic number 1 is how to actually take this website and deploy it live to the web so that other people can go interact with your NFT and purchase it there. Okay, so my assistant Zed has done a really great job of helping, put together this masterclass, and he has actually recorded a bonus video for the website deployment portion of it. It's pretty easy to do. but he has done the step-by-step instructions for that. It's in a separate video. So if you're watching this live tonight, there's a link down in the YouTube description. It should say like website deployment instructions. All right. If you're watching the video vault, it should be there. If you're watching, from an email replay link, it should be there as well. So that's the first thing, is how you actually deploy this website live to the web. So the next thing is going to be how to actually deploy this to a layer 2 scaling solution on Ethereum. So what is that? Well, there's a lot of complaints that Ethereum is kind of slow, it's expensive. One of the solutions to this is actually layer 2 scaling solutions, where you can make Ethereum faster and cheaper to use. Because sometimes people think, hey, I'm not going to pay a ton of money to just send an NFT around. Well, that's what layer 2 scaling solutions can do. And so there are resources down below as well. There's a bonus video to show you how to deploy your NFT masterclass to a layer 2 scaling solution. Again, Zed is in that video for us. And we have the coding resources for that particular part of the presentation tonight and that bonus video as well. All right, so yeah, that about wraps it up for today, everybody. Let's go ahead and move on to time of question and answer. We got some good questions already in the chat here. I'm going to answer those right now. So basically, somebody says, how can you control the number of tokens that are minted? So that's a good question. So the first thing you want to do is go into your source images, source backend, scripts, and then gallery. And however many pictures you have in here, this is how many tokens are going to get minted originally, all right? So if you want to actually enforce the overall scarcity, though, inside the project, basically, you can essentially transfer the ownership of the token, or you can call the minting finished function, okay? So if you look at... yeah, I think with this particular thing, that the easiest thing to do is going to be to just transfer the ownership of the token where nobody owns it anymore. So basically, whenever you mint tokens, you have an owner. All right, and so this owner is the person who's able to mint them. And so if you want to enforce that no more tokens are minted, you can basically just transfer the ownership to like invalid address, like so it's like 0x0. It's essentially burning the ownership. And there's actually a function inside the contract where you can do that. So MetaMask desktop typically just supporting cryptocurrency tokens, so ERC20 tokens. So you don't have to pay to host your images on IPFS. Okay, so somebody asked how to dynamically generate the art for the NFT. Okay, so if you want to do that, then basically you have to, the generative art portion will be separate from creating the token. So you've got the token side of things, you've got the place where the images can go. You'll still want to basically have the image in a way. You can do one or two things, right? You can do number one, pre-generate images. And so you could basically, have some sort of programmatic way of generating, maybe 1,000 NFTs. And then whenever you've done that, then you just save the generative images, inside of here. And then basically those are your pre-generated images with different character traits, and you just go ahead and pre-mint them and people can buy them. So we're talking about actually users generating the images before they mint the NFT themselves. That's going to be a little more advanced. Okay, so that's going to be number 2, live generation. So basically, in that case, you're going to need something else to control the token smart contract and some more sophisticated coding that's basically going to accept certain characteristics, all that type of stuff, and then it's going to actually call this mint function for you. If you want to do more variety, then this is the easiest way to do it. All right, and this is because you can do it pretty much with everything you have here tonight. This is going to be a little more challenging. Can you mint one at a time over a period of a year, or all the tokens have to be minted at once using this process? No, so you can mint them over time. It's just that, basically you'll have, you won't have any, the customer won't necessarily know that you're, like, the scarcity won't be enforced on the blockchain, because who knows when you're going to mint them, I guess is what I'm trying to say. Now, you can pre-mint them and unlock them over time in a way that the blockchain controls. But, yeah. But if you want to manually mint them over the course of a year, you can definitely do that. Somebody says, how about nested token? Any suggestions on it? So maybe you have a more specific question. I'd be happy to answer that. Somebody says if they want to mint 50 of each token. That's a good question. So basically, you could go to your mint script here. And this for loop here, it goes through all the files length. Basically, you could create some logic in here that essentially does it 5 times. I think you said 5 times or 30 times maybe. You could do 30 times of each minting, or you could literally just create like 30 different images in your project. That would be a way to do it without having to modify the code. They said 50 of each token. So yeah, you could change this to do this 50 times right here in the script, or you can literally just put 50 copies of each image. That would be a way to do it without having to do too much coding. So you do not have to pay anything to keep your images on IPFS. So how to randomly assign token ID and tie it to Chainlink. So that's a good question. So this is assigning the IDs based on the length. So you could tie into Chainlink to get some sort of verified, random ID with the contract. It'd be a little more advanced, but you could definitely do that. So somebody says, can you get recurring revenue when tokens are resold by the original purchase? So I think what you're saying is anytime a token is sold, can you send proceeds back to the person to do it? So there are ways to do this. They will have some limitations. One way to do it would basically be to inside the transfer function for the NFT, whatever the value being transferred in that case is, you could say that a portion of that value goes back to the original creator. Somebody says automatic royalties. That's basically exactly what I was just explaining. So you would do that inside the transfer function. You would basically assign any value that's being transferred inside that transaction. A portion of that value would go back to the owner. So if you wanted to use an NFT as a ticket to an event, would it be best practice to just have a link to a picture of a ticket or add some more functionality to the smart contract? So what I would do is basically, I wouldn't even worry about the image as much as just having the metadata be correct. So basically, name, description, you could have more information about the NFT ticket inside of this metadata right here. And sure, if you wanted to have a ticket that contained maybe, if you wanted to have an image that created a barcode or something like that, then you could definitely store that image with a barcode inside of the image description. Can this be applied to music, a popular song? So yeah, you could definitely put music inside of here. So the music would just be the media. We have NFTs that have videos inside of them. They have, music, all that type of stuff. So an NFT can be burned is a question. Yeah, so NFT can be burned. There's a couple different ways to do it. You could create a burnable NFT, just like we have a mintable NFT. You could create a burnable NFT. You could just send an NFT to an invalid address that effectively burns it. So somebody says, could you lock NFT decryption? So I guess I'm not sure what the question there is. If you can clarify that, I'd be happy to answer. So NFT Mint is its own auth token as a kill switch, EIP 1155. So how to add a trait or redeemable trait like access to event. So you can add traits basically with the metadata, but basically what you would do, redeemable traits like access to events, essentially you would just, whoever interacts with the NFT, that's who determines what the access is. So you could create a separate smart contract that says like, hey, if you own this particular NFT, then you have access to this. If you own this NFT, you have access to that. So some of those things can just be like, hey, we just want to check to see if you own this, and then someone will manually grant you access. Maybe you have a website that lets you download, a certain song from your favorite musician if you are an NFT holder, okay? So all they're going to do is like make you connect your MetaMask, and they're going to check your MetaMask to see if you actually hold the NFT. And if you do, then you have the perk. So a lot of those like sort of special privileges are on the other side of things. You don't really have to customize the NFT to make those happen. So can NFT be any file extension type? So technically it can. Most wallets aren't going to like play a song necessarily. Most of them are images, but you can have NFTs that are videos. You can have them, that are music. It just depends on what the wallet supports. Somebody says, can I make NFT a Matic mainnet? You can do it on Matic because Matic is EVM compatible. So you can take the exact project that we've done tonight and then update your project inside of here. This truffle-config file to support the Matic network. So we've done that before. You can definitely do that. Somebody says, can you create an NFT with multiple images, like one with artwork and one with a barcode? So I would just use the artwork as the main image. I wouldn't do multiple images inside of it. I mean, you could theoretically, put a link to the barcode image inside of this metadata, but most wallets aren't going to read that metadata for the barcode. I mean, theoretically, you can put any JSON inside this file that you want to. You could add any key. You could just say my special trait, and you could just say, trait one or something inside of here. Okay. You can put any metadata inside here that you want to. It's just not that your wallet won't necessarily recognize it. Okay, your wallet's only going to recognize the ERC 721 standard traits, but it's standard data, but you can put whatever data you want to in there. So if you wanted to add a barcode separately, you technically could inside of there, but your wallet won't necessarily pick it up. So can you set an expiry date to an NFT where after this date, it is no longer valid, and perhaps it burns itself by sending itself to its invalid address pre-written inside the smart contract? So yes, you definitely can have some sort of valid date. So what I would do, I wouldn't burn it, but basically you could just have validity, okay? Because you won't be able to really program the ability to like do stuff automatically on the blockchain. But what you could do is you can create a new mapping here, and you can say like valid, is valid. And then basically, whenever you do the minting, you could do custom logic that says like, hey, this is only valid after a certain date. All right, and you could customize this to check the date with the block timestamp, and then that would let you determine the validity based on the date. All right, everybody. So my Zoom recording is going to run out here pretty soon. I have a 2-hour limit. So I'm going to 5-minute warning on questions here. How would you create a dynamic NFT, aka the image evolves based on a certain event? So what you could do is basically have an NFT where the image changes. So you could have multiple images that the contract knows about, and then basically depending on when that event happens, then the smart contract could actually rotate the image that's displayed whenever the metadata is requested. So basically, you would have multiple copies. You could do it one or two ways. You could have like multiple copies of the metadata. Like so, you have one version, version 2, version 3, version 4, with different images based on that state. And then the NFT would know that like based on whatever the current state was, then you could swap out the metadata. The smart contract would swap out the metadata to show the different image based on that current state. So how do we know the value of the tokens? So the price, it's a good question. So the market's going to determine the price. So if you go list your token on something like OpenSea, then the market will ultimately decide it. So it's all based upon supply and demand, okay? But you can just go to like, let's see here. What basically the NFT is going to be worth what people are willing to pay for it. So you ultimately set the price of the NFT in your initial marketplace here. But whenever it gets traded on the public market, the market's going to decide. So, got any questions here? So, where do we set the price of each token? So, the price that you set for your initial thing is inside this mint script. Okay. So, your price is, say here. All right. So how to start DApp with friends? It's a good question. So, if you're part of the membership program, I'm sure there's lots of people inside there who are looking for get some great experience. So I bet you can connect with people inside the Blockchain Mastery Slack channel to find people who want to launch a DApp. All right, everybody, I got to go wrap it up for tonight. My limit on my Zoom call is going to run out here, but it's been a great masterclass. Again, if you are just joining for the one-time class tonight, you'll get a replay link emailed out to you afterward with the video plus all the coding resources. If you're into the membership program, we'll post a replay link to this on a Video Vault, of course, whenever we're finished. And yeah, if you're not a part of the membership program and you want to be, definitely reach out. We can get you taken care of. Again, if you want to get the step-by-step coding instructions to take your skills to the next level so you can really get more in depth on this stuff, I can definitely try to do that in the Blockchain Bootcamp. I'll put a special link down in the description below tonight where you can join at a discount. We got lots of people who are hyped and have gone through the bootcamp in the chat here tonight who are saying a lot of good things. So if you got any questions about that, I'm sure they'd be happy to help you again. So thanks everybody for coming out. This was awesome. If you got any other questions, feel free to reach out in the chat room. So yeah, great time tonight. Catch you all later. Bye-bye.
Hello everyone, this is Zed from DAP University. In this video, I'm going to show you how to deploy the NFT Masterclass project to the web. We're going to use Sage. You can read up more about Sage on sage.sh. The good thing about Sage is that it's fast and it's pretty simple to deploy your static files, which is the front-end files for the project, to a domain. Let's say you want to have the domain dap.sage.sh. I'm checking it just to see if there's anything there. Okay, I can be fairly confident that there is nothing at dap. So Sage is one of the options if we compare with Vessel, Netleafy, Heroku. With one major command, we are able to send our files to a domain. For this project, we're going to follow the simple steps that are in the README file. At this stage, I'm assuming that you have your project working locally with the blockchain contracts deployed to the Covan testnet. So let's follow the instructions here. Command C. We first have to run the build to produce the optimized build folder. We run this command, enter. I'm not going to do it because I've already done that earlier. As you can see, I have a build file here, which contains the optimized production build files. Then the next command, we need to change directory into the build folder. This is where we have the files that we want to send onto the internet. We have to make sure that next command we have Sage installed. Command C, our next instruction. I'm also not going to run this, but you must. I'm going to check I have Sage installed because I did install it earlier on. I have version 0.23, I mean. And then lastly, the one major command that I spoke about, Sage to the domain, our domain of choice. So I'm going to type it in here because that one at the top is just an example. I said dap.sage.sh earlier on. For the first time you use Sage, you might be asked to enter in an email and a password. Please do that. If you do lose your password, you are able to request a reset on the terminal. So it's confirming that I'm about to deploy the build files for the NFT masterclass project. I click enter. The domain is being confirmed, and then we can see that it's starting to load. Just waiting for it to be 100% complete. Awesome. There we have at sage.ch. I'm just going to copy the link. I'm going to put it in my browser. You can also go to this site and see for yourself if the project is being deployed on the web. Let's just wait for it to present the currently running NFT marketplace that I've got, which is deployed to the Kovan testnet. The good thing about Sage is that it's quite fast, and as you saw earlier, very simple, one command, and the build files are sent to the web. It's taking a little bit of time, but I'm fairly confident that the site is ready and it can load any minute from now. Let me just refresh. There we go. That's the site. There we go. There you can see me on the NFT masterclass. I can log in with an account with MetaMask. Let me try connect. There we go. There is my minted collectibles that anyone can go and buy. Let's try to buy one. Confirm. Let's just wait for the confirmation that I'm able to buy this. An alert should work as expected. There is it. Congratulations, you received NFT with ID 3. Okay, thank you very much. In the next video, we are going to deploy the NFT masterclass to the optimistic networks. Cheers. Bye. When it comes to optimism, there's the optimistic local network. This is the same as something similar to Ganache. So this is a local blockchain that you are running on your machine. Then there's